I'll be talking today about putting together the platform. So looking at Riak, Redis, Solr, and Spark, which is a relatively common stack these days. Brief introduction to who I am. So my name is Bryan. I work with Basho Technologies, client services engineer. I've been doing that for just under 2 years. So doing that role has given me a very it's been eye-opening in terms of looking at how people build huge applications, and I only reached a certain level of scale in my own efforts, and now I can see how people do it on a really big scale. Okay, Binary Temple on Twitter and GitHub. So I've got various repositories up there, mostly repositories that are forked and have 1 or 2 changes, but a couple of my own as well. Okay, so what we'll be looking at is minimum viable product. So, I mean, this is a kind of ideologically correct doctrine at the moment, and the kind of permanent excuse for never refactoring your code. So you start with what you have, be it written in PHP or shell scripts or Perl or whatever it is. You solve problems as they arise, due to typically demands for new features and limited resources to implement them. You get to the point where you can't scale, and you use a more scalable solution. Usually incrementally, you just bolt stuff on as you go. Okay, so we'll take the example of someone like Best Buy, one of our customers, humongously large, one of the top 10 internet retailers. Kind of similar to Argos, or the US version of that. And obviously at some point in the past they must have started out as a tiny little web store before they grew or were injecting a vast amount of venture capital. So we take a look at kind of the evolution of a site like this and how it go from something just quite small to something that ultimately serves hundreds of millions of customers. Perhaps concurrently, perhaps that would be an exaggeration. Okay, so we've all written these. Who has ever written a web store here in this room? What have the other people in this room started their careers? Is it a programmer audience, or what kind of split is there here? Who writes code? Okay, what do the other people do? UX, Ops. Right, so there's UX, one UX guy, and everyone else development. Right, it's acceptable. Who here has ever heard of Riak? Yeah, have you used it? Yeah, a little. In the case of those who've used it, what have you used it for? Just on your own laptop messing around? 7 database in 7 weeks? Yeah. You haven't. Who has? Good. All right. Fair enough. Okay, we'll get to what Riak is a little bit later in the presentation. Okay. Which is good because it makes the content, which I've got to share, more interesting if you start from the point of knowing nothing. Okay, so basically looking at this example, it's pretty straightforward. You could have written in PHP, Django, Ruby on Rails, Magenta, whatever. There's a million ways to do this. If you want to, your sessions are stored in a browser cookie. A really ugly way of doing this is to store the user sessions into a relational database as well as they're modified. It's a great way to not to scale. And in this case, the card is mutated, it's written to the database. So what you might do is you might have a certain amount of inventory for a given item. People put it into the shopping cart. You send a write to the database transaction. You say, we started out with 100 items. Now somebody who's put it into a cart and said there's 99 items available. And at some point in the future, your abandoned carts, they time out. The exact logic for doing that will probably be a big old SQL query. And items are returned to the inventory. So it's similar to perhaps if you have a ticketing system or if you're reserving seats in a cinema or something like that. Everyone's written that type of code, yeah? not as ugly as this implementation, but everyone's broadly speaking created something like that at some stage, yeah? Okay. So, a system is, well, there's two outcomes. One is failure, in which case you don't need to write any more code and you can move on to your next job, your next project, or whatever. And the other consequence could be success. And success is a double-edged sword. Makes more money, attracts more venture capital, and your system slows down, and you have to look at ways of speeding it up. Okay? So, scale is not. A couple of years ago, scale was something that happened when you were hugely successful. But these days, a lot of companies are generating or processing a lot of data, while they're still at a very small size, startup size. So, for example, Temetra, it's an Irish company. They may be based in Dublin. If not, nobody's perfect. They've created these smart metering devices, and the idea is to reduce the maintenance cost of boiler repairs and stuff like that. So that's the core business model. They've got millions of users, 10 million meters in the EU, and a very small DevOps team. It's about 4 people. For each meter that they've got, for a traditional meter, you've got maybe 4 data points per year, so automated readings or whatnot. With theirs, it's 35,000 data points a year, so they're measuring multiple times a day. This is a very common use case. There's many companies doing this type of stuff. But what's notable is not the fact that there's many companies, but that there's many small companies doing it, and they have limited resources. Okay, that all makes sense? Is broadly true, or is there anything highly contentious I might have said? Yeah. Huh? Okay. So more users or more data equals slow read performance. So the typical thing that you do, I've done it before. Is anyone here a Java developer? Yeah, cache, Terracotta. There's a bunch of products around that space. Anyone ever used Hibernate or JPA? Yeah. Okay, so it's easy to hook into those type of APIs. You use an object relational mapper, you plug in a cache into it. And how easy did you find to use the Hibernate caches or the JPA caching systems to configure it and deal with caching validation and everything? Yeah, exactly. So we've got 2 scenarios. At this point, okay, we've got latency increasing, but the data is not cached. The caching there, there's different ways to skin this particular cache. You can read from the database yourself and manually populate some kind of cache. Some people refer to it as cache warming. No longer in contact with those people. You'll need caching validation logic, so you pull data into the cache, then the data underneath is mutated, so you have to write perhaps a hook or something like that. It's difficult to write a hook in a relational database unless it's Microsoft SQL, which goes out and does something. Not necessarily a good thing. And it's starting to get a little bit more troublesome. Okay. So then at that point, somebody says, well, we've got our web store, that's great and everything. Now we need to support mobile clients. So at this stage, you'll reach for some Node.js or something like that, maybe Python, depending on how you're orientated, and you write yourself a little microservice, typically, or you could just use a huge application server. It's up to you. So at this stage, you've got a demand. You're supporting not only the web client and the mobile client. It increased the complexity somewhat. How do you coordinate the caches? I mean, you've got a microservice here and a microservice here. They're both using some kind of caching mechanism, be it in memory or whatever, and you've got a relational database. Do you write an API layer on top of the caching system to ensure that it's consistent? It's pretty unlikely, because human nature being what it is, rather than refactoring that product to support something like that, you'll probably just write another service and run infer from the existing code. It's entirely possible. And write locks are still an issue. Okay, so then at this point, somebody comes along and they say, we would like you to make the data searchable. I've implemented this myself in the past. Back in the Hibernate days, there was some integration between Hibernate and Lucene. Lucene begat Solr, Solr begat Elasticsearch. You get some idea where that is. And it's kind of tricky. Sometimes writes fail. Sometimes indexes aren't generated. Concurrency can be an issue as well. But it is something that, with proper diligence and attention, you can implement this, okay? But it's not the easiest thing to implement. Well, I mean, in the scale of problems, with here being the hardest problems and here being the easiest problems, it's not up there, but it's time consuming nonetheless, okay? So it could take several weeks to implement this feature. Depending. I mean, it's entirely possible. You guys just write code faster than me. Highly possible. Okay, so at this point, we're at the stage of growing pains. We'll start doing some things, and there are some kind of indications, like suddenly get a nasty rash around your neck. You might say, well, this could be a symptom of a disease. And there's symptoms for this kind of situation as well. You start reaching for SQL profiling tools. MySQL, I'm not sure where they're at the moment, but you can get some reasonable results there. Obviously, if you've got a large budget and you like a GUI, Microsoft SQL Server provides some very nice functionality there for query profiling. But I don't use Microsoft myself, but it looks good. The search is separated. Maybe it runs as a standalone service. You have to populate it, so you're going to have to develop some kind of system for every time the data is updated in the database. New products are added in, or perhaps you've got a series of comments which are added after each product index or product listing, but that data is indexed as well, so you want to make it searchable. And that's not the easiest thing in the world to do. I've previously experienced working with Sphinx, which is kind of a C++ GPL equivalent to Solr. I spent a lot of time creating those indexes, building up the incremental indexes, building up the long-term indexes, merging them through. Sometimes it would fail. I wasn't quite sure what was in the index. The easiest solution then is just to index everything again. And you kind of get into the stage as well where there will be some kind of queries in your system, perhaps the query that populates the index, and you never want to run that query. Okay. Does that sound familiar, or has anyone ever reached that kind of plateau level of sophistication in the product? You've never built anything this complicated, no? No. Yeah, of course you have. All right. So this stage, the kind of feature backlog continues. So we're into the situation where, in addition to all this kind of stuff, you've also got to deal with scale and availability. So your database server crashes, or you have some kind of problem with your network switch, or somebody is connected, maybe some BitTorrent clients to your network, or kind of irresponsible administrator behavior that I've never seen, but I've heard about from other people, friends of friends. And you start having to deal with scale and availability. So faster requests consistent level of latency so that not only you've got a high throughput of requests, but also that individual requests aren't spiking. So, you know, it's no good having like a 5 milliseconds response if, you know, every once in a while it takes 30 seconds to return something to a client. It's not good. So I'm going to show you a couple of reasons why React would be a good choice for the core of such a platform, and you can kind of decide for yourself if it sounds the same. So what is React? React is a new generation of database, relatively new. NoSQL movement has been around for a little while now. It's got a masterless architecture, in which every node in a cluster is capable of serving read and write requests. So traditionally, with relational databases, you have a master server and you have a transaction log, so every insert, every update, every delete, they're fed in, maybe they're sent in plain text, maybe they're encoded in some fancy way, but fundamentally, transactions come in, reach into the databases, and typically you're not going to be performing updates on the slaves, because then you could get into a kind of weird situation. It's kind of self-evident. Have you set up systems like that before, or experienced running them? It's standard stuff. Okay? So React is slightly different in that React, you create a cluster of nodes. By default, you replicate the data to 3 nodes. When requests come in, kind of responsibility for your data is sharded or partitioned across the cluster, typically into 64 pieces or partitions, but you increase it to much larger numbers. And any node in the cluster will be capable of servicing a request. So in the case where a request comes in here, we say that this is the node that's responsible for a given partition, which is determined by hashing the key for that object. It fetch the data from itself, and it will also fetch 2 copies from 2 other nodes. Compare them, ensure that the data is consistent, you have the same thing, or the missing values will be written back to the appropriate place. And same for writes, you write a couple of copies. So if you lose a machine, or you lose 2 machines potentially, in this setup, you still have 1 machine that's able to provide a copy of that data. And that data, let's move on to the next slide. This brings us on to the top slide. This brings us on to the topic of write availability and consistency, and are they mutually exclusive? Poll of hands, are they? I mean, if you think about it, it's a fairly simple answer. If you can write, you can always write into the cluster, and it's able to accept writes in the event that some of the machines are down. It could mean that you have 2 copies of your data. So back to the question, would you consider that they're mutually exclusive? It might be a prize for whoever gets the first right answer. I said might. Okay, so the answer is they're not. Or they are mutually exclusive. If you're in the situation where you can write multiple copies of the data, there's no kind of system coordination occurring, guaranteeing that they're all written at the same time. It is impossible to guarantee that they'll all be consistent. You could have multiple copies of the data. Okay. Has anyone ever dealt with this in any other system? Has anyone ever used a masterless kind of database system like this before? No? Elasticsearch, all right. So what you got to do in that situation, and this stuff is kind of, we wrote this with like an assumption that people, you know, would have more people in the audience with prior knowledge of React. But what you're going to do is deal with conflicts, okay? So you've got 2 copies of your data. So let's say you loaded in some contacts from your phone, and maybe you loaded in some contacts from some other device, and maybe you modified some of the same contacts, and maybe the network split. Not all the machines were able to talk to each other. I might have taken Joe Blogs, I'm going to put in his phone number on one entry, written it off to the cluster, and I might have taken his email address and his name and another card. We've all got this in our mobile phone, the ability to merge conflicting address book entries. Maybe nobody else using a BlackBerry. It's rare. Same with this. A situation like that, what Riak will do is that it will generate siblings. We'll say, well, I've got 2 copies of the data. I've got no idea of how to resolve them. Okay? What it does then is that the next time that data is requested or read, it returns both copies to the client. The client will decide how to merge the data. So in that case, it's pretty simple. You just make a union of the data. Okay? Set those attributes. That makes sense? Reasonable? So a relatively recent improvement that we made, nobody else got this, just us, is Riak data types. So Riak data types are a series of data structures that, rather than taking the entire data structure, I didn't mention that Riak was a key value database. It's just an object, it's just a blob. Rather than taking the entire blob down into the client and mutating it, when you want to add something into a list or you want to resolve a conflict, you can now use these Riak data types. What they are, again, it's still a blob, but it's stored inside the cluster, and you send operations to the cluster. So you say, add something to a set, add an element to a map, increment a counter, decrement a counter, and Riak resolves all that stuff inside the cluster for you. Does that make sense? Does anyone have any questions? No? What else do we do? Cluster replication. So it used to be the case that Microsoft, Amazon, BBC, big organizations who have data centers in multiple locations. It's no longer the case. I have servers just running my own personal account all over the world. It's gone from being the unusual to being the norm. Who else here has got servers in another country? Yeah, all right. We expected more. Maybe the others are hiding something. Okay. So another thing that Riak does is multi-cluster replication. So you shoot your data into one of these clusters, network split or no network split. You've got all this resolution and stuff going on, and you can then copy it into a cluster in another location. So you can have a data center in New York. Does anyone else use Linode? No? No respect. No. So you can have a data center in New York. You copy some data into there, say it's your product catalog, fires it off to the London data center. So you got your data center. So you got your data is moved closer to where your customers are. Obviously, I presume everyone has noticed that there's a big difference in latency between making a request to, say, a UK or a London data center and one that's on the West Coast. It's pretty, you're all kind of familiar with that. You've pinged at some stage. No? Never tested speed? Okay. I most commonly notice it on Netflix. So dealing with search at scale. So you go to distributed full text search, so we support that. We support the index synchronization. So just as multiple copies of your data are written around a Riak cluster, so multiple copies of the index are written around the cluster. So you have 3 copies of your index. If one of those machines fails, that index gets deleted. It can still serve requests from the other duplicates. And it will also, it's got an automatic healing feature. It's based around a feature we have called active anti-entropy. Back in the day, we used that for repairing missing objects. Now we also use it for repairing index entries that are missing. So we scan through periodically, we see what's in the index, we see what's in the corresponding Riak partition, and what's not there we write. We keep that up to date. And auto restart. Riak is written in Erlang, which is esoteric, but has some very nice features, particularly around process coordination, starting processes transparently on other machines, and process supervision is one of the key features of Erlang. we've extended that. A process can either be a process inside the virtual machine, or in this case, an operating system process, because we're running a JVM with Solr. We didn't re-implement it in Erlang this time. Okay, any questions so far? No? All right, making this easy. So, at this stage, we've improved search. It was relatively easy to do. And we're one step closer to success. So at this stage, where we could be, and this is kind of the transition we see relatively frequently, if not always. You get your legacy infrastructure, you've got your product catalog stored in a relational database, or it could be some kind of inventory system. God help you, you're running SAP somewhere. You got a pipeline, so stuff's getting updated at the warehouse or as it arrives, or whatever. You're putting that into some middleware, which is either, in this case, we've specified Python, Ruby, Node, but we could extend this list almost infinitely using it. You know, we include Java, Scala, etc., etc. Some people are even going to do it in Perl successfully, which is astonishing, given it's 2015. You're taking it into middleware, you're transforming it into JSON, you put it into a Riak KV, or Riak cluster, and it's indexed and searched via the integrated into the Solr. It's applied to web and mobile, but the thing that's missing out of this picture is caching the Solr results. Okay, so move on. How am I doing on time? Good?
You're supposed to finish, right?
Is it?
13 minutes. What time are you
How long?
supposed to- 13 minutes.
Alright, so how quickly are we moving? Alright, okay. So Basho data platform, okay? So let's move a little bit faster. So the Basho data platform, what it provides, caching there. So what we've done, basically Redis is intensely popular. I've used it before, found it very, very nice to work with. Has anyone else here a Redis user? Great. It's the simplest thing in the world to run. It's trivial, incredibly easy to write a client for. It's only just little text messages. If you could write a client for SMTP, you could write a client for Redis, easier. All right. One thing about it though is that it's kind of difficult to scale it out. It runs really well if you've got it running on one machine. Provided, I mean, in my experience, I found that adding items to a list, you keep pushing items into a list, eventually when it grows large, it becomes very slow to pop them out of the other side. Go figure. Should have read the docs there. So what we want to do is provide a easy-to-use caching layer, automatically indexed search, so we got that with Solr anyway. Scalable, highly available persistence there. Simple React, trivial, it's just there. And simple pipelining to data analysis. We take a look at how we structured this. Okay, so the fundamentals of what's in there. So at the core you got Riak, obviously, we make it. Provide a service management system, so that would be providing some functionality that's a little bit similar to Zookeeper. I don't know, does anyone use Zookeeper? Is it easy?
No.
I got the Hadoop book a couple of years ago, but it's like chapters were too big for me. So Service Manager in conjunction with Riak Ensemble. Riak Ensemble is the system that we developed to provide strong consistency. So it provides a Paxos-like algorithm. The original intent was for particularly what we mentioned, this is eventually consistent. The idea was that you could have particular objects in a particular bucket configured in a particular way, and that you'd be able to guarantee that you could read your own writes. So in a situation where you had a network partition, if there wasn't the majority of the nodes available on your side of the partition, you wouldn't be able to do a write to that object. Just cut a long story short, that's the essence of it. So we use this, provide a leader election service for Spark. Spark, has anyone used it? Yeah. Spark is the next hot thing, basically. People are moving from Hadoop onto Spark. It provides a kind of standard way to query a bunch of different data stores, provides partitioning over data sets, provides integration with a whole load of machine learning libraries. It's quite easy to use and very particularly easy to use from Scala. Is anyone a Scala developer here? It's good. So the 3 years that I spent learning Scala wasn't a waste. It wasn't done out of fashion or anything. It's good. So there's two kind of ways that you can use Spark. The first one is to just fire up Spark, add in dependencies, start up a Scala REPL, or whatever other way you do it. I don't know, there's Python as well. Has anyone worked with Spark with Python? Okay. PySpark. I need to find out more about that, actually. Maybe we'll talk after. So you can either do it that way, and you can say, take in some arbitrary data sources. So they could be a CSV file, it could be an associative array, whatever it is. Or you can also run like a Spark cluster where it distributes work, queries and operations that you're performing around a bunch of worker nodes. Okay, one of the features of that is that you have the master, and it's basically performing the job coordination, collating the results, etc. And you've got a bunch of worker nodes. Now, at any given time, you only want to have one master node. So traditionally, you use Zookeeper there. And the idea behind Zookeeper being that you have one consistent view of certain values opposed to an entire cluster. Okay. Zookeeper is a little bit difficult to configure and set up and keep everything. There's a certain operational overhead there. So that goes away, okay? In the service manager, we've got Riak, we've got Redis, so we've got Basho Redis proxy. So what we do is we apply the same kind of partitioning logic, which we use for Riak, so the way that it distributes data out amongst the cluster nodes. And we apply that to Redis as well. So we can put Redis in high available, very little operational overhead. Just basically, you deploy a bunch of Redis services in a group and monitors them. If they fail, it restarts them. It also moves the data around between the different instances, so you get a more reliable access to your data. At the moment, it's limited in the operations it can perform, so it's basically we're using it as a pull-through cache, which you can also populate yourself as the result of from the results of Spark. So you can take your Spark result set, populate it directly into Riak, or you can populate it directly into the Redis cache. Okay. Does that make sense? All right. Okay. So we're running a little bit low on time, but I'll try to fly through these next slides. So we've discussed caching. And Redis. Why? Okay, so why use Redis with the data platform? What led us to this decision? Okay, so our story has always been one of high availability. Redis has always been, its story has always been blindingly fast throughput. I mean, unless you write the code yourself, it's very difficult to get a higher speed than you get from a Redis data store. It's great. But it's not particularly built for scale. I know from reading their website a little bit recently that they have made some steps towards a more high availability setup or some kind of system of master-slave synchronization, whatever. It's not really at the core of what they've tried to do. Riak is being built from the very first instance is being built as a distributed, highly available database, and that's been to use a term of value proposition. It's what it's all about. So with the Basho data platform, I mean, these numbers are funny because you're always going to find that the speed of a cache hit is disproportionate to the speed of a raw access to the underlying data store. But you know, some numbers, basically, if the data is cached, it's going to be a lot faster. It's also got pull-through caching as well. So if you want to, you can warm up the cache with a predefined series of requests and we'll pull through the data from Riak behind the scenes and warm it up in that way. Has anyone here ever engaged in cache warming? No? Okay. Okay, so we've got a couple of slides just about basically how it fits together. So with the service manager, currently there's just two services that we support, which are Redis and Spark. The implementation itself is very simple, so it certainly will be within the capabilities of most of the people in this room to deploy their own services there as well. Basically, we're talking about at its most fundamental level, just a little bit of watchdog code. Is the process alive? If not, start it up and feed a little bit of configuration into the cluster. So, I mean, there's no point in launching a bunch of Redis nodes if you don't know what IP address and port they're listening on. So that's some of the glue there. So yeah, that's basically it. You build a cluster, you run a simple command, you deploy a bunch of Redis nodes into a group, and then Basho data platform, Riak, monitor them, ensure that there's resilience. When nodes goes down, that will be available in the cluster state, or restart nodes. You can also configure it in such a way that, let's say, I want to have a minimum number of nodes running at any given time. So, you know, it's 5 potential instances, but I want 3 of them to be running. Okay. So we've got some resilience. And then a kind of feature set around that. Characteristics of Redis, 2.8 version. Is anyone using Lua Scripting with Redis? Just out of curiosity. Okay, of the people in this room who are Redis users, how many is that? Do you think that Lua Scripting is a good idea? Indifferent? Ever used it?
Never used it.
Did you ever think about it?
I thought about it. I think about a lot of things.
Yeah, I really didn't like the fact that Lua went in there. Okay. Okay, so you can use the basic operations, get, set. Set uses a TTL. We've all used TTLs with Redis, one of the winning features. You can also use a couple of commands to expire data. Pexpire, info, monitor, straightforward stuff. You've done it before. And then the Basho data proxy. It's written in C. It's a read-through cache in a 1.0 version. Write-through cache is a future product feature we're going to implement probably pretty soon. It's E only at the moment, so it's an enterprise feature. Pre-sharding and connection aggregation is built in. Okay, so we take a really quick look at the analytics. I've kind of covered this already, actually. Spark client, provide that's an open source project, so you can actually just use it against an ordinary React cluster at the moment. It's on GitHub. But really, to get the value from that, you want to be running a Spark cluster. Just kind of quick diagram of how that stuff's laid out. This is kind of high availability story that we've got for the Spark cluster, and quick comparison of Spark and Spark Cluster Manager. So Cluster Manager is shipped as a jar in the BDP extras package. There's 2 packages. There's the BDP package and there's the BDP extras package. BDP contains the core of it, and the BDP extra package contains things like drivers, libraries, stuff like that you might want to have on the server. You don't strictly speaking need it. You can download it separately, but it can be handy if you need to jump on a server get on a REPL and start issuing commands, queries. Yeah, and again, we covered the fact that it stores as metadata. It uses the Riak strong consistency mechanism in order to store its cluster metadata. So you're guaranteed that there's only one true version of across the cluster. You can either access a true version of the data, or you can't access it at all if you're using strong consistency. That's the kind of guarantee that it gives. Okay. I'm back again, looking at the Best Buy website, how it could potentially look now. Somewhat simplified, so you get your mobile client, your web client. They're using cache proxy, making use of Redis, automatically going through to Riak KV and populating if need be. Your search is integrated, so every time that you update your data, rather than having to do it at the API layer, as a software developer, you just fire it into the system. There's a hook there which gets it indexed. The indexes die, it recreates them. You know, you just don't have to deal with it. And finally, analytic services with Spark. So you've got your Spark cluster, and it's also talking into Riak KV. We've made some modifications there, which will be making their way into the open source version of Riak as well. That's related to pre-fetching data when you're doing queries and some partitioning improvements as well. And the kind of benefits you get from that. So obviously faster analysis, more IOPS, and faster reads if you're using Redis, relatively balanced. I think that is nearly the last slide. Any questions? Yeah. What was the question?
So, how does BDP compare with Basho's Marathon?
Whoa, we'll have to cover that after. I mean, provide a written answer. Any other questions? It's worth noting that we're providing Mesos integration at the moment as well. Alexander Sickler has provided that, some work that we did in conjunction with Cisco. But if anyone's interested, we can certainly provide some more information after or put them in touch with him. Any other questions? No? All right, so the website is there. It's on the internet. It's surprisingly easy to access, and also to download a copy of Riak, which you can use for your own entertainment. Twitter handle is Binary Temple, also GitHub, mentioned that. And you can get all this good stuff. So you get the Basho data platform, you can download that. Two versions, open source and enterprise. The fundamental difference between open source and enterprise in the space of 20 seconds is that the enterprise version provides the feature of MDC, so that's multi-data center replication, and it also provides the ability to run multiple Spark worker nodes. So obviously you can contact us to get started, and remember to rate this session favorably. Thank you. Thanks. This is subliminal. Thanks. This is subliminal, isn't it? Thank you.